Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 20 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3443. Maximum Manhattan distance after k changes. So let's read the problem statement first. You are given a string S consisting of the characters N, S, E, and W. Okay, north, south, east, west. Where S of I indicates movements in an infinite grid. Okay, N means move north by 1 unit. S means move south by 1 unit. E means move east by 1 unit. And W means move west by 1 unit. Initially, you are at the origin 0, 0. You can change at most k characters to any of the four directions. Okay, k value is given to us. Find the maximum Manhattan distance from the origin that can be achieved at any time while performing the movements in order. Okay, the Manhattan distance between two cells xi and yi and xj and yj is xi minus xj plus yi minus yj absolute value. Okay, addition of this. All right. Okay, so see this example number one. Input string is like this. Okay, so here if I just draw the directions, so this is nothing but your north, south, east, and west. Okay, so now here if you see in this example number one, first we are moving to this north. Okay, and we are starting from this origin only, right? That is nothing but 0 by 0, right? Initially you are at origin. Now if I move up, right, so my this y value is increasing, right? So here 0, x value is going to remain 0 and y value is going to become 1, right? Now if I just calculate the difference among them, okay, here like this xi minus xj, so 0 minus 0 is going to give me 0 only, okay, absolute value, plus 1 minus 0, it is going to give me 1 only, right? This value is always 0, right? From the origin only we need to check. Okay, maximum Manhattan distance from the origin, right? So let's suppose in the end I am somewhere here, right? So from this to origin, right? So let's say at this position we have coordinates like this, you can say xa and ya maybe. Okay, so from origin you want to calculate, right? So can you write your formula like this: xa minus at origin plus here ya and here origin. Okay, this is always origin, right? So why we need to write? Okay, so I can simply do this now: xa plus ya, right? I can simply do this, right? xa plus ya, right? So here in this case, instead of this 0 0 plus 1 you can do, and you will get a 1 only. Okay, right? And then right now initially you are starting from 0, right? Now you are getting 1. Okay, so 1 is the max as of now, right? Then after that you are moving west. Okay, if you are moving west, right, so here your y axis is going to remain same, but x is decrementing. Okay, so here it is going to become minus 1 and this is going to become 1 only, right? Here see we are taking the absolute only, right? Absolute only. So minus 1 absolute is 1. This absolute is also 1. 1 plus 1, it is nothing but 2, right? So 2 is the max so far, right? So I need max only, so I am going to write 2. Okay, now here if you see we are moving south. Okay, south means to this direction. Okay, so if I move to this direction, my y here my y is going to decrement it. Okay, x is going to remain same only, but y is going to decrement to 0. Okay, so now I'm getting minus 1 and 0. Okay, so I can say 1 plus 0. Okay, absolute, so I'm getting 1 only. So right now 2 is the maximum only, right? Then after that east I'm moving. So now if I move east here, see, first north, then west, then south. Now if I move east here again by 1 unit, I reach back to origin, right? 0 by 0. Okay, now I'm getting 0, but in see, max distance that I'm getting is 2, but my output is 3, it is not 2, right? Why? Because here k value is given to us. Okay, and what we can do with this k, you can change at most k characters to any of the four directions. Okay, so now if instead of this s, right, if instead of this s, if I just change it to n, okay, if this, I change this character to n, so now here instead of moving this, if I move to this top position, right, okay, so my x is going to remain same, my y is going to be incremented to 2. Okay, so now I am going to get 3, right, and then if I move to here, then my here x is going to change, but y is going to remain same, I'm going to get 2, but here I'm going to get 3, right, and we need max, right, so maximum Manhattan distance from the origin that can be achieved at any time while performing the movement. Okay, so we are going to run one loop, and we are going to side by side check the max value that we are going to get at that point of time. Okay, and in the end we have to just return the max. Okay, so here after 3 it is going to decrement to 2, but we are going to return 3, right? So here we are changing one direction. Okay, so here change s2 from s to n, the string s becomes this, right? So here first Manhattan distance is 1 maximum. Okay, keep tracking of maximum, then here next time -1 -1, so we are going to get 2. Okay, maximum is this, then we change this to north, okay, from south, so now we are getting 3 Manhattan distance, max 3. Okay, then we move to east, okay, only one we can change, right? So here we are getting 2. Okay, so here it is going to remain 3, right? Okay, this is clear what we are doing, right? So this is what we are doing in this example. Okay, and this is the same new example, example number 2. Here also if you modify this s1, this to w, and 0 1 2 3 4, okay, this to w, your string s is going to become like this, and using this you are going to get the max out. Okay, but how we know that we need to change this only? Okay, this is the next question, and these are the constants. Okay, so now let's understand that. Okay, so here uh, let's suppose this is your graph. Okay, this is nothing but north, south, east, and west. Okay, so now in your code, here nswwew is there. Okay, nswwew is there. All right, so now here if you see this vertical line, okay, so in this vertical line we can go to north or we can go to south. Okay, so here we are moving to north just one time. Okay, we are moving to north just one time, and that's it, and then we are again moving back to the south. Okay, again moving back to the south here. Okay, again we reach here at this particular position, right? Okay, now here to the west we are moving 3 times. Okay, 3 times, so one time here, one time here, and one time here, and then we are moving to the east just one time. Okay, then that simply means here. Okay, here, so in the end if you see, you are going to be here, right? If I just follow this, so north we are moving up, and south we are moving one time, okay, down, and then west in total we are moving 3 times, and to the east we are moving one time. So in the end you will be here at this particular point. Okay, right, this is where you are at, right, in the end. Okay, so from here if you just calculate the distance, what you are going to get here, let's say this is 0, this is -1, -2, -3. Okay, this is nothing but 1, this is -1, this is 1, okay, this is 2, right? So now here you are at this particular position. Okay, so x-axis is -2, and y-axis you are at 0. You are going to get 2 absolute value only you need, right? So you are going to get 2. Okay, right, you are getting 2 only, right? But we need what we need max. Okay, this is not the max, right? So here if you see from this what you are doing, so here north, okay, this is north and this is south. All right, so this two distance how you can get, so north here, right, and south. Okay, and minus s absolute value among them, so we are going to get 0 only, right? And if I just do the addition of this with east minus west, okay, absolute value only, east minus west, so you, what you are going to get, north count is just 1, south count is just 1, west count is 3, east count is just 1. So you are going to get here 0, and east minus west here 3, 1 minus 3 minus 2, absolute 2 only, right? So you're going to get 2 only with this formula. Okay, if I just do take the absolute value of this. Okay, so I can say that this is nothing but the number of norths, okay, number of south, number of east, number of west, right? So, and this is clear now, right? If you see, let's suppose you are moving to north, okay, and then you are moving sometimes to south, you are here, let's suppose. Okay, now you are moving here, let me write the directions also: north, south, east, west. Okay, now let's suppose you are moving to east here, and then again there are very less w, you are here, reach here. Okay, so until here you need to calculate, okay, Manhattan distance. This is what you need to calculate, right? So you can easily calculate now this value, how you're going to get this value. So this value, if you see this axis, so in this axis what we are doing n minus s absolute value. Okay, then we are reaching here. And in this plane, okay, in this line, what we are doing east minus west. Okay, then you are reaching here. So this is what we need to do, right? Okay, so with this we can get this distance. Okay, right now I am not applying this k value or anything yet, but this is the basic that we are doing, right? So this is how I'm driving this formula, right? North and south and east and west. All right, now here, let's suppose your north value is 5 and your south value is 2. Okay, so now here, let's suppose east and west both are 0 0. Okay, don't worry about them. Okay, so if this is your uh, graph, okay, so here east, west, north or south. Okay, so north you are moving 5. Okay, north you are moving 5, 1 2 3 4 and 5, and then you are moving south 2. Okay, here, so you are here. Okay, you are here, right? So now distance among them is nothing but north minus south. Okay, 5 minus 2, 3 is the distance. All right, now here tell me, let's suppose your k value is 1. Okay, your k value is 1. Okay, so now in this case you can change any one direction. So let's suppose you change this one south to north. Okay, so n n n n n s s. Okay, let's suppose you change this to n. Okay, so now here what you are doing, you are changing one south to north. Okay, so what will happen here, north count is going to become 6. Okay, and south count is going to become 1. Okay, so what is the absolute value that you are going to get now? You are going to get 5. Okay, previously what was the value? 5 minus 2, previously it was 3 only, but now you are getting 5. Okay, so plus 2 is happening. Okay, plus 2 is happening. And if you want to understand it visually, so here we are removing one south. Okay, we are removing one south. Okay, so here we are removing this arrow and we are adding it here. Okay, so now see, I can just simply remove this. Okay, and this arrow I can just simply place it here. Okay, so now from here you need to calculate this. That's good. Okay, so changing just one direction, okay, and it is impacting by plus 2. Okay, this is what I want to tell you, right? Okay, but here in this case we are changing this s, okay, which is occurring less number of times. We are changing the s which is occurring less number of times among this north and south. But if I change this n, okay, so initially my n is 5, s is equal to 2. The distance that I was getting is nothing but 5 minus 2, that is nothing but 3. Now here I am saying if I change this n to s, okay, if I change this n to s, right? So here let's suppose this I change to s, right? So s value is going to become 3, n value is going to become 4. So now here what I'm going to get, 4 minus 3, 1. Okay, and here minus 2 is occurring. Okay, minus 2 is happening. Okay, this is just 1, right? Minus 2 is happening. So if I change the value, okay, which is occurring more number of times, right, that is going to reduce the Manhattan distance. But if I change the value which is occurring less number of times vertically, right, that is going to increase the distance by plus 2, right? Okay, so from here we derive one more thing, that always try to update the direction which is occurring less number of times. Okay, in this vertically line. Same thing we need to do for the horizontal line also. Okay, east and west also. Okay, whatever is the minimum, we have to update only that direction. Okay, this is what I want to say, right? Okay, clear? Right. So here in this example, if you see north, south, west, west, east, W. North, south, west, west, east, W, and K value is 3. Okay, so north is occurring one time, south is occurring just one time, W is occurring 3 times, east is occurring just one time. Okay, among them, what is minimum? Okay, you can pick any one of them, right? Both are occurring just one time, right? So among them, you can take any one direction. Okay, right? All right, so here you can pick anyone, right? And you can change that since we need the maximum, right? So let's suppose you are changing your south to north. Okay, you can do that, right? So then what is the Manhattan distance that you are going to get? You are going to get 2 right now. Okay, you are moving up north 2 times. Okay, done. Then you are somewhere here. Okay, you are somewhere here. Now here it is saying west is occurring 3 times. Okay, 1 2 and 3, and east is occurring just one time. Okay, you need max. Okay, you need max value of x and y. Okay, maybe negative and maybe in positive, right? Minus 6, we are always going to get 12. Okay, or if it is 6 we are always going to get 12. Okay, so now here in this direction, k value is 3. Okay, so we change this for one vertical line. Okay, now for horizontal we are checking. So W is 3, E is 1. Okay, take the minimum one. E is just 1. Okay, so E is 1 and K value is we already changed one K value here. Okay, so K value remaining is 2. Okay, out of this 1 and 2, which should I change? I should change the minimum of them only, right? Okay, minimum value. Okay, 2 or 1. Okay, minimum is just 1. Only 1 is there. No, we have to change minimum 1, right? Okay, if E is 5, then we have to just change 2. Okay, that is the limit. But here E is itself is just 1. Okay, so we have to change, take the minimum only, right? So only 1. So if I change this E to W, let's say, okay, so then this arrow is going to move to this direction. Okay, and in the up, you are going to get your y as 2, and in this you are going to get minus 4. Okay, so here for absolute value you are going to take 4 plus 2, that is nothing but 6. 6 is your output. Okay, very simple. That's what you need to do. Let's write the code with this approach. Okay, first let's try to write this code. Okay, so here create one variable answer and set it to 0, right? And take north and set it to 0 initially, south set it to 0, then west set it to 0, and east set it to 0. Okay, done. Then after this, just iterate over all the characters in your string. So you can say char, here you can say s dot char array. Okay, let's see, char c. Okay, this particular character. Okay, now here inside this you can write if else condition. Okay, so we have to check side by side also, right? Okay, since in the problem statement is saying find the maximum Manhattan distance from the region that can be achieved at any time while performing the movements. Okay, so we have to check side by side everything. Okay, so if character is equal to north, okay, and capital N, then increment the value of north plus plus. Okay, north plus plus. Same way here, else if the character is S, okay, capital S, then you need to operate south plus plus. Okay, then here else if character is east, okay, then you have to operate east plus plus. All right, and else if the character is west, okay, W, then you have to update the west plus plus. Okay, west plus plus. Done. Now here we have to find out the how many times we can change any particular direction. Okay, so that also we need to check side by side, right, every time. So here I'm just going to call one I'm going to write one variable. Let's suppose int times 1. Okay, let's suppose this is for your vertical line. Okay, so here first we have to find out north and south which is minimum. Okay, so math dot min among north and south. Okay, among them we have to find the minimum one, right? Okay, so now we calculate minimum one. Okay, but we can only change it k times, right? K is a limit. Okay, so here among this also we need min, right? Among this also we need min. Okay, so here also I'm going to write math dot min. Okay, k is the limit. Okay, so if k value is greater, then we are good. Okay, then we are going to update bit over the minimum. But if k value is less and min among them is greater, okay, then only until k only we can do, right? So here modification times for n and south. Okay, north and south, right? This is for north and south or vertical line. Okay, same thing you have to do for uh, horizontal line. Okay, so here I'm just going to write times 2 math dot min, and here instead of north I'm just going to write east, and here instead of south we have to change it to west, and also here instead of k some value we have used in this times 1. Okay, so I'm going to use that here times 1. Okay, this is done. So here this is nothing but the modification times for east and west, right? And then you have to calculate the answer also side by side. So answer is just going to be the max value. Okay, so math dot max, and here uh, previous value of answer. Okay, whatever the max we have to keep track of this, and here I'm just going to count. Okay, count. So here count this and count this. Okay, so how we are going to get the Manhattan distance? So here uh, this north minus south plus east minus west. Okay, so what you need to do here in this count. Okay, I'm just going to pass. Okay, count is, let's suppose I'm calling one method. Okay, so in this I'm just going to pass north south value. Okay, what is the value of north, what is the value of south, and times 1 value. Okay, times 1, right? We are just going to change north and south, okay, based on this times 1, right? And same way here in this count also I'm just going to pass east, west, and times 2 value, right? So here this answer is going to keep track of the max value, and from here I'm just going to return the answer. All right, this is done. Now here let's write the code for this count. Okay, that is also very simple. Private int count. So in count what we are doing, we are passing two directions. Okay, int direction 1, int direction 2 we are passing, and we are just passing the times. Okay, times value, times, let's say. All right, so here inside this what we need to do, we have to just return the absolute value of, okay, math dot absolute. Okay, and here what we are doing, north minus south. Okay, right? So here you can simply say north and south. So here we are passing this variable. Okay, direction 1 you can say, and minus dir 2 you can write. Okay, and how many times we are changing? Okay, north and south, among them whatever is minimum we are changing that. Okay, right? So times 1 time we are changing, right? So every time we are going to change, that is going to impact plus 2. Okay, that is going to impact plus 2. Okay, because we are going to change the minimum one only, so that is going to impact plus 2. Okay, so whatever absolute value we are going to get this here, from this I'm just going to add times value into 2, into 2, that's it. Okay, so calculate the modified Manhattan distance. Okay, so this is going to give me that. Okay, same before, east, west, and times 2 I'm going to pass the variables, and I will get some value, right? Now let's run the code and see if their code issue will try to fix that. So yes, so here s dot char array. Okay, so just change it to 2 c capital char array. Now let's run it again. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are clear with this approach. Okay, approach 1, right? I can say approach 1. From here we can further modify this problem, okay, using this approach 1. right? So what we are going to do here, instead of calculating like this north and south, okay, we are taking four variables: north, south, west and east. We can simply take two variables here, latitude and longitude. Okay, so here, okay, instead of going like this north and then south, okay, let's consider them a single group. Okay, and let's consider this as a latitude. Okay, whatever the latitude value you are going to get here in the vertical axis. Same way, if you are moving here or here, okay, so let's consider this line as a longitude. Okay, so what I'm going to do here, answer set to 0 only. Here let's consider number of steps you are going to take. Okay, number of steps you are going to take, and here instead of south you can simply say longitude, and here instead of west you can simply say latitude. Okay, and just remove it. Okay, just remove this part. Done. Okay, this is your first step. Then here everything is going to remain same. So for north, going up and down, so that simply means that you are going to play with your latitude. Okay, so here just write it. Okay, so if you are moving up, so latitude, okay, mountain height is increasing. Okay, but if you are moving south, coming down, then let's say mountain height is decrementing. Okay, right? And if you are moving to the east, okay, so you can simply say that longitude is increasing. Okay, longitude plus plus. Okay, and if you are moving to the west, you can say your longitude is decreasing. Okay, so longitude minus minus. Done, right? And here you are going to take steps every time. Okay, so steps plus plus. Okay, moving one character. Okay, move to one direction, you are taking one step, right? Every time you move up here one step, up here one step, up here one step, come down then next step. Okay, so you're moving steps. Okay, now here instead of this you can simply remove it. Okay, and here answer is equal to math.max answer math dot. Here instead of this count you can simply do one thing. uh, Here let me just simply remove this. Okay, this part. So here you can simply write math dot abs value of, okay, absolute value only we need. Okay, so latitude, latitude, latitude. Okay, copy this, latitude. Okay, plus the math dot absolute value of math dot absolute value of, and here longitude. Okay, and here every time what k times we have to do now, we have to take the minimum only. Okay, since we know that in both the direction what we are looking for the minimum value only. Okay, so north and south, whatever is the minimum we are taking that. East and west, what is the minimum we are taking that. Okay, so we are dealing with the minimum only, right? So here every time you are also know that impact is with k into 2, right? Okay, here this, and here you have to just pass the steps. Okay, number of steps, step, we are taking step only. All right, and just pass this complete also here. Okay, whatever you are going to get from here in the math.main. Okay, math.main, right? So now here this is not required now. Okay, you can remove this. Now let's run it. Okay, so here let's see first if we are able to pass all the tests. Nice. Okay, now let's understand why we are writing here step. Okay, and what is happening. So let's understand this. Okay, so this you already know that why we are doing, right? From the analysis and approach one, we can observe that the optimal strategy is to modify the less frequent letters in both directions whenever possible. Therefore, if we treat the less frequent letters in both the vertical and horizontal directions as a single group, we can reason as follows. If the total number of such letters is greater than k, then modifying any k of them increases the Manhattan distance by 2 into k. Right? But if the total number is less than or equal to k, then all the less frequent letters in both the directions will be modified and no further modifications are necessary. In this case, the Manhattan distance becomes equal to the length of the string, right? So let's say after 3 steps, your latitude is 2 and longitude is -1. So Manhattan distance is going to be 3 only, right? Now k is equal to 1. So best possible gain is 2 into potential distance. Okay. So here, if you just do the summation of all this, you are going to get 5, right? But you are just taking 3 steps, right? I is equal to 2 means at 0 1 step, at 1 step, and at 2 1 step, let's say. So only 3 steps taken, so max possible distance is 3 only, but here you are going to get 5. Okay, so that is why we are taking the min also here, right? And since we need max, so for that purpose we are taking max. All right, so now let's submit it. So see, our solution is accepted, right? So I hope that you guys are clear with both approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.